Okay, thanks everyone for coming. I'll be hosting today since Kyle isn't here. There's not a lot on our agenda. I'll be talking about some new things with FastAI that I've been working on. And of course, if there are any other topics that you want to bring up, just say something or write something in the chat. So the first thing that I wanted to show was the new documentation for FastAI. Just share my screen. Okay, can you see it?
Yes.
Great. Okay, so I demoed this a while back in an earlier call, but now finally FastAI is also running on the new Pollen documentation system, which has this hierarchical layout where you can always click through on things and look at documentation and source code at the same time. And it has all the content that the earlier documentation system had. Just a little nicer to browse, and you can also search now, look for training. Yeah, I think it should make it easier to browse. I also have some plans on content to add to this. There's an issue. Where is it? Documentation overhaul. With some plans for more documentation, and I just need to get to it. You can always suggest some more content that's missing. I think there's some open issues on that, but yeah, so there's definitely more coming there. The documentation system Pollen now also has some early documentation. So finally bootstrapping itself, documentation for the documentation package. So if you want to try it out, you can follow this tutorial, and in about 10 minutes, you should have a Pollen project set up. I actually just did this today for one of my other packages. And if something doesn't work, just let me know. This should work. There's also some more information on how this actually builds the documentation and all of that. So just wanted to show that. And then the main thing that I want to be talking about now is an addition to FastAI. So FastAI already has this functionality to load datasets and to load dataset recipes, where you can get a nice data container for training, given some data that you want to use. So here we say load the ImageNet or ImageNet dataset, so that I can use it with an input image and a target label. That's the format I want, and then you can plug that right into the learning task and train it, right? So I'll be showing now something that takes this idea a little bit further, called feature registries, which for now ports most of the functionality, but also adds some. So this is currently PR, but should be merged soon. The idea is to have basically tables or long lists of features, different kinds of features that FastAI writes to, but also third-party packages can contribute to. So here's one example, just the data sets. These are all the FastAI data sets that are hosted on AWS. And we can list these, we can see some attributes, we can see if those are already downloaded. So it makes it kind of nice to browse them. There's a lot of them, obviously. We can also look at one of those and get some more info. For example, this image roof, we can see it's already downloaded, get a nice description, and then finally we can load it, which in this case just initiates the download if we haven't downloaded it already, and gives us the path where the files are stored. So this is one example of a feature registry. But as I showed in the docs just now, we also want to load those datasets into a format that's suitable for training already. So there's also a registry for dataset recipes, which is of course always associated with a dataset. But the addition here is that you have some block information associated with the recipe. So, example, this ImageNet dataset, we can load it into a data container that has where every observation is an image and a label. So classification task, right? Again, we can look at a single entry of this, and it'll look up the data set, download status again, and then we can load it. And this is just like load data set is behaving currently. You get a data container and the block information. You can use this to load a little dog. And another registry is the learning tasks. So the different tasks that you may want to train on, currently just supervised tasks. So a lot of classification, single label, multi-label, the key point regression, image segmentation, and the tabular tasks. The only ones in here right now. Also, again, associated with the block information. This kind of unifies the feature discovery functionality that was already in FastAI, now with a consistent API. So we can look at a task, then load it and instantiate it as we would any other. And then just like this, we can already build a learner out of it, right? We got the data recipe with the container. We put the blocks into the learning task, and then we have a learner that's ready to train. So aside from just creating these humongous lists of features, we can also filter the entries. So for here, for example, we take the data sets. We want to look at only those that we've already downloaded. So this is the downloaded column. So we match those on true, and that have a description. So where the description is not missing, if I change this to is missing, it actually should show something. Fix that. But yeah, so that also makes it easy to find some feature that you're interested in. Here, for example, we look at the recipes and use the block information to filter. So we say we want to see all recipes that have a two-element observations where the input can be anything and the target variable is a label. So these are all recipes that can be used for classification, right? So we have some image classification tasks here mostly, and I think not shown here, but there should be some tabular classification recipes as well. We can do the same thing with the learning tasks and filter on the blocks. Here, for example, we say the input should be an image, and then we get all the supervised image tasks like classification and segmentation. And the idea behind this really is to make it easy for users to discover the features that are there, and also easy to contribute features to FastAI, be it in the core or in a domain-specific library. So if someone makes a library that adds time series support to FastAI, then they could add recipes, they could add data sets. In the future, also other things like models, maybe loss functions. Those are all things that could be kind of registry and learning tasks, of course. And then using the same interface, the users will be able to find those features. So you don't have this problem with, I mean, you have a streamlined way of accessing the information. I also plan to use this to build some rudimentary no-code interfaces. So as you can see, through this block information, by kind of matching different things together, you could, I will try to build a Pluto notebook where you can drop down, you can select a block or maybe a data set, start with that, and then it'll show you all the compatible tasks, or from task, all the compatible data sets, and then you can kind of mix and match those features and build a whole training pipeline and train a model without needing to write any code. Yeah, so this, I hope to merge this in the next week. And in the future, there will be probably more registries for different features as well. Yeah.
Very cool.
Thanks. Daria is asking if the no-code stuff would be based on Pluto UI. Yeah, so using the registry information here, you could build some drop-down lists, for example, with the matching features. So you can mix them together. Yeah, so, oh yeah. And one more thing that I wanted to mention here is that soon the domain-specific functionality in FastAI, like the computer vision and the tabular, will move into sub-packages, living in the same repository probably, but really embracing this modular aspect. And then the registries will make it easy to still access the features, find the features that you want, and have other people contribute functionality. Yeah, that's everything I wanted to show today. Are there any questions, comments? Very good. Any other topics for today?
I had a few updates.
Okay, go ahead.
Yeah, so for GSOC, thank you everyone who put in their proposals. We have a couple others who have been sort of, corresponding with. For example, we have a really interesting proposal coming in for neural rendering as well as real-time rendering systems. So we have a bunch of work going into how we had the ray tracer demo, but we want to basically spruce that up to actually include modern renderers, as well as obviously making sure that they're defensible, including interesting applications such as neural rendering. So we have real-time renderers that are about to, if we want, we can definitely look into those. The author of one of the papers for volumetric neural rendering has reached out to basically see if they would be interested in, or if he would be interested in sort of like a collaboration or as a GSOC project. So that's pretty exciting. Another thing that we have going, I was able to use the distributed data parallelism training to train for instance segmentation, semantic segmentation tasks. So both the deep lab as well as NASCAR CNN, which we have implementations of, as well as I would probably split off the Coco Pascal data loading as well as the ImageNet data loading out of that, just so that it's easier for FastAI and stuff to sort of hook into those if required.
Very cool. Are those based on the ResNet ImageNet repo? The distributed training?
So there's two aspects to that. One is that ResNet ImageNet, I was thinking if we should probably release that properly now that it's pretty stable, and we've been able to train multiple tasks and multiple models and so on, and it scales fairly linearly, at least on single node, as well as for multi-node. There's a little bit of overhead, but that comes from the distributed library for the most part. So if you were to replace that with a smarter scheduler, then you can sort of ameliorate most of the cost. And that's kind of where Dagger is. We were able to show Dagger's flux training pins out of neural PDEs as well. So that was on multiple processors, but also multiple nodes. And it could, with the same design, we can target multiple GPUs as well. We target multiple GPUs for things like image classification anyway, so it's not really any different. So that's exciting. That means that I put in a bunch of testing time for both Resonance ImageNet as well as Dagger Flux to make sure that the results coming out of those are correct, as well as something that we can rely on, so that we're pretty sure that we're training the right thing, we're doing the right thing. The other thing is that I have sort of a working prototype of re-implementation of how the chain works. So the one thing that has come up recently is I'm sure you guys would have seen explicit flux layers and simple chains, right? And we've had a lot of discussion separately about why we need a chain implementation and where the explicit implicit sort of differentiation lies. And one of the ideas was to basically parallelize over the data as well as layers. Currently, we do only layers, and the thing that simple chains introduced was the idea, or for that matter, fast chain or fast dense from the SciML ecosystem, was that for smaller models, it made sense to do it over data. So that's an implementation that I have been benchmarking. It should be mostly just a drop-in and should scale with threads and so on. The only thing for that is that we will definitely need some additions to Zygote to basically support threading. Currently, our tasks infrastructure works with like 1.6 something, but it broke with 1.7, so we need to basically patch on that so that we can make sure that Zygote understands tasks. But with that, we should be able to parallelize over, differentiate over parallelized code with just the tasks as well. So that's exciting. Another thing was that I sent in a PR to Metalhead. I noticed that there was a lot of regression in terms of time to first gradient. And turns out that the issue largely lied with how we were constructing the models. So I have a very, very basic PR on Metalhead right now, which more than halves or 2.5 times faster than master on time to compile, which is still slower than what we were at 0.4 or 0.5. So one of the things that we, or at least I'm interested in doing, is making sure that we can also make sure that these models can be compiled fast enough, so that A, we're improving Zygote, but B, we're also improving the libraries, so that how do I say this? It was a real big pain. The compilation time to train all the models like that took a lot of time for iterative processes, you can imagine. So that's where the motivation came from, really.
Yeah, that's great. The compile times are going down.
Yeah. So I mean, if anyone wants to take a look, review, whatever, send in your comments, and hopefully we can get a quick merge, because it's a fairly simple change.
Mm-hmm.
But yeah, we also might have we have some work going into MLOps in Flux now. So we might have been able to secure some funds to get proper support for something like WGS Machia and stuff like that, so that not only are we able to bring that up to speed with the rest of Machia, but also have backends that can be easily hooked into to produce specifically MLOps type workflows for not just Flux, but SciML, and all the rest of it. So that's exciting, but that'll take a little bit of time to bear fruit.
That sounds cool.
We have a call about that this week.
Is there already something public that someone who's interested can take a look at?
Not
something
really, but I
to
think
keep
Simon
track of it?
would. I think we'll be able to say more once we have certain things in place. For the first thing is that we need WGS market to sort of be updated to the same kind of submodule ecosystem that Machia has going. The second thing is that we want specific implementations for like a I don't want to say a pure Julia because the pure Julia MLOps isn't that exciting. What is exciting is that we're able to take this and use it in basically any kind of workflow. And rather than having this whole chain where you have to rely on PyCall and so on to actually interact with many of these backends, right? We are now able to do things like polling and not disrupt the training process at all and update the training as it's going and stuff like that. So it's pretty exciting, but we'll know more concretely, I guess, in the next call.
Cool. Yeah, definitely to update. That sounds
Yep.
exciting.
So there's been a bunch of stuff going on. Thanks.
Cool. Thanks for the updates. Anyone else want to bring up a topic? Otherwise, I would say we're end early today. Thanks for coming, and see you in 2 weeks.